operate on matrices, we can operate on vectors.
They're column or row matrices. Here's an example of a very simple matrix. Let's look at, we'll call it matrix A, and I'll go 1, 0, 2, 3, negative 2, 7. Okay, and that is a matrix, as we have learned about in the previous couple of chapters. But so is the matrix B equals, let's see, 0, 2, 7. This is a 3 by 1 matrix, where this one is a 2 by 3 matrix. And I'm actually going to move this piece here over a little bit, and I'll introduce matrix C, which is, let's go, negative 1, 3, 5. And that is a 1 by 3 matrix. And these two here, matrix B and matrix C, can be viewed as vectors as well. We might use this notation, or we might use, for example, negative 1, 3, 5 with these angle brackets, they're called. In some rare cases, you'll see parentheses, negative 1, 3, 5, and you have to determine from the context that what's being talked about in this last case here is a vector and not a point in R3. So there are several different ways to write these matrices. I'm going to erase a couple of them here. And I'm going to focus now on what we called matrix scalar multiplication in the previous chapter. I can't remember if it was the previous chapter or the one before, but if I want, for example, 3a, then I'm literally going to take 3 times the matrix 1, 0, 2, 3, negative 2, 7, so that I end up with 3 times every entry, 3, 0, 6, 9, negative 6, 21. And I can do the same thing with B. Let's go 5B is 5 times each of the entries in the matrix B, which is 0, 10, 35. And if I want negative 2C, I just multiply negative 2 by each of the entries in that matrix. This one really should have commas in it. And that's going to give me the matrix 2, negative 6, negative 10. Okay, so that's just a quick review on matrix scalar multiplication, but these two cases here, B and C, can also be viewed as vectors. In particular, your textbook uses this form for writing vectors more commonly than this other form, although you'll see it both ways. So I'm going to focus on this form now, and I'm just going to remind you that this matrix scalar multiplication, when applied to either a column or row matrix, can be viewed as being applied to a vector. So we now know how to do scalar multiplication of vectors. If I have, wrong pen, if I have a vector v that's equal to 1, 0, 0, 1, 2, for example, then negative 7v is just the matrix, or sorry, the vector, negative 7, 0, 0, negative 7, negative 14. And we've only been working with integers here, whole numbers, but I want to point out that scalars can be any real number. So in fact, let me just go back and I'll just use vector v again. This time I'm going to multiply it by, let's say, pi. Pi times the vector v is going to be pi 0, 0, pi 2 pi. And negative 1/3 times the vector v would be negative 1/3, negative 1/3. Oh, no, sorry, I got my zeros in the wrong place. Let me back up a little bit. I got my ones in the wrong place. Negative 1/3 times 1, negative 1/3 times 0, negative 1/3 times 0, negative 1/3 times 1, and negative 1/3 times 2. So it's literally a case of multiplying that scalar through the vector.